Hey guys, this is a very informal cast. It's myself and my friend Brandon looking at some Komshine fusion splice equipment. It's straight from China, very affordably priced. I don't know that much about fusion splicing. I haven't done it a lot, but my friend Brandon has done it for years. He's got a lot of experience. There's a lot of sort of tips and tricks he actually rolls in here. So I know for you audio only guys, there's going to be some things that we're talking about that maybe you can't see it, but there's a lot of really good tidbits in here. I know this one's a long one as well, so strap in and hold on if you can help it. Again, for any of you guys listening that don't happen to know, we do have a Patreon account now. It's patreon.com/TheBrothersWISP, so jump in there and support us in any way you can. Thank you guys. Bye. All right, here it is, the Komshine.
Man, they start to look they look all the same now.
Don't they? I think they're probably mostly made by the same manufacturers, don't you reckon?
They look like they're made by the same manufacturer, and they're just like there's like a Walmart version, and then there's like a a Macy's version, I guess you could say. Yeah. So.
All right. So it's got a little USB port in the back, so I think it like keeps track of every splice it does.
Yeah, you can actually. You can actually hook it up to a monitor too. Some of them let you do that, and you can actually see. Because some people are like, are blind, they can't see this, and so they put it up to something else and see it better.
Oh, that's cool.
So, it'd be cool if you could actually hook that up and put that on live. Anyway.
Yeah, I know very little about this thing. I fiddled with it. Griffin and I were able to like fusion two pieces of fiber together, but it took us a half hour.
A half hour?
Yep.
Yeah.
So, it's fun though, isn't it? Pretty cool watching it go together.
It's neat. Alright.
Alright, what else I got here?
It gets pretty bright,
so we got some wipes. I don't have any actual cleaner. I think I was reading that you're not supposed to use alcohol anymore.
They technically are not supposed to use alcohol anymore. Some people say it's always good.
This thing you shake the camera, babe.
You got the longer one. Okay, you got the longer sleeves.
Yeah, I've got a bunch of those things, and then I got right here, I've got this cleaver, this beaver cleaver. I'm not sure if it's dialed in just right or anything like that.
No, let's give it a try first before we start calibrating.
I got this thing too. What is this thing? I don't have a clue what that is.
Oh dang! Let me see what this is. I don't know what that is.
I don't either, but it was in that kit.
It looks like a. It looks like it's so then when you strip fiber, there's two layers, of course, two claddings. Okay. And so that's what it looks like. It looks like you put it in there and you take that cladding off.
Explain to me what you're talking about.
So let me show you a piece of fiber.
Yeah. I'll get you one.
You mean the one that you already played with?
That doesn't matter. There you go.
Okay. So let me see. That's been a while. Let me see if my hands.
Fiber.
Let me see if my hands are steady still.
A regular stripper, right? How much do you usually strip off of this stuff whenever you're doing it?
It depends on the sleeve actually. So the longer your sleeve is, the more you pull back. But anyway, for this one, I would go back almost like 2 inches for the most part, because I would get the sleeve first, and then I would get the cladding off, and that's what I would do. Why is this thing timed? Let me see the menu on this bad boy. Auto. Let's see here.
So it's got auto, manual, and full auto. I know I've got a little manual, but it's no fun. I figured I would just ask you what it meant.
Let me see. Okay, a single move. So, okay, I know what that. Go back. Where's the U?
The menu?
No. Well, I guess that too, but
yeah,
there's a reset. But there we go.
Oh, if you're just looking for a straight up reset.
Nah, I don't want to do that.
There's a reset button on the outside.
Here's our test. We should probably do that first. Let's do an art test here in a second. That way we can actually get this thing going.
So these strippers, they have kind of two little slots, right?
Yeah, they do.
So one is for the outside jacket, right?
Yeah, most for the outside jacket. Most of the time, these already come the way they're supposed to be, right? So there's no extra like checking or anything. These things are ready to go.
It looks like it's got the ability to dial it in a little bit if you need to.
Yeah,
I guess
there is, if you need to, depending on the size of the jacket. And depending on what fiber you're using. So for the most part, like this right here, like you're going to cut it here, and it's not going to do it automatically. Okay, so you see how it exposed it right here?
Yeah.
And it might have nicked. We're gonna find out real soon if it nicked that fiber.
Kind of looks like it might. I got some scissors right here if you want to trim back some of that. What's in there? Is that just like some kind of nylon or something?
Yeah, so this nylon is basically a way to keep the bend radius correct. So every fiber is like anything else, just every cable's got a bend radius of some sort, right? So Kevlar basically helps it. It doesn't do anything special. Some people in certain places, they want to use it as a strength member to tie things off. In a jacket like this, the only time and place you would use it is whenever you're actually putting a connector on. And that's about it. So nothing fancy about that. But the same thing, the reason they have the Kevlar and the actual outside plant stuff is the exact same way. They use it as a strength member in some ways, and they use it as a way to keep the bend radius.
Fiber wherever it comes in, like near the bulkhead, it'll that inner member, that nylon, they'll have it like tied off to something, right? Is that just to keep the cable from getting pulled?
Yeah, and you can, like let's say a strength member, you can tie it to something, you can tie it off to anything. So let me see here. Man, it's been a while since I touched this.
All right, so the outside's the jacket.
Yeah.
The inside, the white part right there, what do you call that?
This is an inner jacket, and then on this jacket, on here, you have cladding.
Okay.
So I'll show you here in a second if I can let me get my hand steady here a couple times. And you'll pull this off right here. And there should be an inner cladding right here on the outside. Let me see if I can get this started right. See right here? See what I'm pulling off right here?
Yeah.
Okay, so that's cladding on the outside of the fiber. I don't know if you can see that very well.
Yeah, back up just a little bit.
There?
Right about there. This thing can't focus too close.
Oh, okay.
Yeah, it just kind of looks like it's peeling off.
Yeah. So you're peeling that cladding off right there, so you can get to basically a bare fiber.
So you shouldn't be afraid.
Yeah.
You're not hurting the glass.
No, you're not doing anything.
Pulling out the outside cladding.
Yeah.
So what's that cladding made of? Is it just like a plastic?
Some of it's plastic, some of it's glass. The good stuff is going to be glass.
Really?
Yeah.
Okay.
Yeah. Cheaper stuff, it'll be plastic. For something that's really short distance, it's going to be plastic. For example, like if you're doing, what's a good way? Like a laser, not like a. What am I trying to think? More of like LED, I guess you could say, instead of an actual pure laser.
Yeah, like a multi-mode.
Yeah. You're going to use more of a plastic instead of like pure glass.
Okay. So really, you're taking your strippers and you're sort of turning them at about a 45-degree angle, and then pulling them out.
Yeah.
All right.
And then what you're going to do here is that after you finish that, is take one of these and you're going to.
Are you supposed to moisten the thing, or you just wipe it clean just with a dry cloth?
There's different people that say different things, right? So different people will tell you that they'll dab it with some kind of cleaner and take it and wipe it and it'll be done. I've done it both ways. I've done it wet and dry, and I've gotten the same results. So it doesn't really matter as long as you definitely know you have a clean cleave. And you'll know, let's see. So on this cleaver, after you set this.
This little handle right there, you lift it up, and the whole sort of apparatus comes up.
Oh, good.
So, yeah, looking at it, I didn't know exactly where to put it in there. I know it came with this little plastic guide. I'm not sure how you're supposed to use any of this stuff, to be honest with you.
Oh, it's going to be... Actually, this looks pretty helpful, actually.
I saw some cleavers online where those graduation marks were actually built into the apparatus, which I thought was kind of cool.
This could be helpful. I never used this before.
I don't think it'll fit in the holder though, so I'm not sure what good it is.
No, I don't think it will. You could use it on maybe this is meant for something else. But yeah, I mean, this is extremely helpful. So what you would do is that since you have your jacket already here, you would know exactly where to line it up. So if you were to place this,
is this if you're just doing connectors? Like if you're putting connectors on there? Because I mean, if you have pre-terminated pigtails, you don't. I mean, do you really need to know how much bare fiber and stuff there is? You
do only for the splicer. Okay. So does that make sense? Yeah. So if you already have pre-terminated pigtails, it's you don't. It's just good to have because it's always good to measure, right? Because you don't want to leave. You don't want to leave when you put the sleeve on, for example. Do you have another one? Okay, you got those. Okay. When you put the sleeve on, right? If you leave it too short or too long, I can show you too long. The sleeve, when you heat shrink it, right? When you heat shrink it, if you leave it too long, it'll be exposed, right? So now you have exposed fiber.
Right.
So that's why it's always good to know your measure. After a while, you just kind of know what it is, depending on what you're doing. If you're doing outside plant, you kind of know in your head, like, oh, okay, I'm going to cut this. And inside plant's the same way.
So whenever the heat shrink closes down, it needs to bite that white jacket, right?
Yes.
Okay.
Yeah. Because there's almost like a resin in here. So when it heats up, it like forms almost a cladding again around that fiber. Okay. Does that make sense?
Yeah. And so it seemed like inside this, there's like a little inner tube, and then there's a piece of steel on the outside, so that just gives it strength, right? Yep. So it's really just to protect it, keep it from bending and breaking.
Yeah. Fair enough. All right, let me test this bad boy out real fast. See if this thing is right or not.
So I know when we were kind of faking it, didn't seem like it wanted to cut clean. Maybe every time, I don't know. Maybe we were just doing it wrong. But it seems like you pop it in there, you close the apparatus, and then you push that little drawer on the bottom forward.
Let's see. Let's give it a try. Yeah, it didn't stay in there. Dun, dun, dun. Yep.
So this thing doesn't have a garbage can attached, and most of the cleavers you use actually have that.
Yeah, and it's actually very helpful because you actually can get, I guess you say hurt by one of these things.
Hey, you get cut.
You cut it. So you actually can get hurt by these fibers. You can actually get stuck in your finger and not notice it for a while. And, you take that to your eye or something.
Yeah. Has that happened to you before?
No. It's been stuck in my finger, but not in my eye.
Right.
That I've done before. Yeah, you don't notice it until later all of a sudden. And it does feel like a splinter. Because you're trying to, you feel like you got something in your hand and you're just like, I can't see it. And you have to get a good contrast and you're like, oh, that's what it is. And you get it out. So, okay, so let's see what we got here. How's this gonna line up? Let's see how this lines up. Pretty good so far. Not bad.
Alright, so it looks like there's a couple little blue tabs right next to the electrodes. And so how much do you want it to stick past the little blue tab?
That's what we're gonna do right now. Actually, we're gonna do an arc test because it kind of calibrates how close it is. And so, look at these. I'm gonna show you something too real fast, just so you have your own knowledge, right? I'll put this down. It's probably gonna mess up that cleave, but it'll be okay.
Right.
Okay, so look at these electrodes real fast.
Yeah.
Okay. So these electrodes are pretty worn. Okay, you can see that tip on them. See how it's almost, I don't know how to say it. It's the contrast between the outside here, the silvery part, and then that point of the electrode. You see how it's worn? These electrodes might be past its due.
Really?
Yeah, so there's only so many times you can lose the electrodes, right? So most of the time they tell you 1,000 splices up to maybe 1,500 splices is the best for electrodes. And then you have to replace those things. Because what you'll end up getting is that you'll get splices right, but you'll get splices with loss. And it'll tell you on here what the loss is, and the loss may tell you maybe it's 0.1, which is a good splice. Industry standard for the most part on a splice is 0.3.
Is that 0.03 or just 0.3?
0.3.
Oh, that's not bad.
That's not bad at all, right? That's really... And most of the time these splicers get way below 0.3. If you do it right. If you do it right, it's below 0.3. So this might give you a good splice, say this time, but maybe the 10th time it won't give you a good one.
Okay.
That makes sense. So you have to cut it, redo it all over again, and you're just wasting time.
So these little electrodes, can you clean those, or do you just throw them in the trash?
No, you have to throw them in the trash.
All right.
You do. I mean, industry standard is about 1,000. I mean, probably tops is 1,500 for a set of electrodes.
Okay.
And then you're done. You have to get a spare set. Most kits, when you buy, let's say you buy one, you're going to come one used. They'll come with a fresh set in here, and they'll give you one set of electrodes.
Okay.
And then, like I said, that's good for 2,000 splices.
Yeah. I mean, electrodes are probably pretty cheap, right?
They're not too bad. They're not terrible. I don't remember the pricing now, but I remember the time we got them, it wasn't a big deal.
Probably like $20 or something.
No, we're looking closer towards probably like 100.
Oh, really?
Yeah.
All right. What about straight from China?
From a 8-year-old kid? Probably cheap. Hammer out electrodes at the house? Yeah.
Yeah. I want somebody in their crib forming electrodes. Yeah.
He's probably,
Well, no, I mean, think about it. Like, all of this kit, everything you're seeing here came straight from China.
Yeah.
On a boat. So I'm just curious, I don't know. I'll look it up. I bet it's
it's cheap. I bet you can find it.
$20 or something.
I bet you could probably find it. And honestly, fiber splicing has gotten so much cheaper over the years.
Yeah.
So splicing fiber isn't what it used to be like 10 years ago,
Yeah.
or even even 5 years ago. It's so much cheaper to do it now.
You know, it's funny. I was at Wispapalooza, this wireless ISP conference, and some guy had a fusion splicer there, and it was it was smaller than this, believe it or not. And at the top, it actually had the heat shrink apparatus, but just below that, it had a built-in cleaver and stripper. Or no, did it have a stripper?
That would be cool if it
No,
did.
I think he stripped it. No, he stripped it himself, but then he put it in there and closed the lid, pushed the button, and then the cleaver came out, and then dropped it in the trash can. And he pulls it out, and then he sticks it in the fusion holder right below it. And so it's everything save for strippers. And so everything was moving. Everything was an independent piece, so it operated independently. So you could have the top of it heating while this was fusioning and this was cleaving. I mean, it was just all in one motion. It was really cool to see.
That was really cool because you can do that if you know what you're doing quickly. I'm gonna say quickly. If you know what you're doing and execute it in a really efficient way, you can do that. Just what he's saying, right? You can go from here to laying one down, put another two in there to heat to the heater to laying it down, letting it cool off. So before it used to be a one-man job. Before I left my job where I did this all the time, it was a two-man job, and man, you could roll with this thing. If he's got an automatic cleaver, which probably makes it even better because you can probably get cleaner cleaves that way, which means you're going to get a better arc, which means better loss.
This guy, he was doing a demo for me, and I recorded it. I put it up on YouTube.
Yeah.
But, the cool part was he, from start to finish, strip to put it in the machine. He tried to arc it, and it said bad cleave, the right side. He pulls that out, recleaves it, puts it back in, and then to completion, even with that mess up, it was like a minute 20 seconds.
That's good.
Like all in.
That's good.
So on average, I think it's supposed to be like 40 seconds.
That's really good.
Yeah.
If you can do a splice every 40 seconds after all your prep, because your prep is the longest time. It's never the splicing that's going to take a long time. It's always going to be your prep. So your prep takes you, especially on an outside plant, it's going to take you a couple hours to set up everything. And then if you can do a splice in 40 seconds, yeah.
Just to have your splice can ready, your wallets, I guess your cassettes or whatever you call it to go inside, all the fibers arranged the way you're ready for it. Yeah. That's what you mean by prep, right?
Yeah.
Just having everything ready to go.
Yeah. Because if you do an outside plant or even an inside stuff, right, your cassettes are ready to go. Everything's laid out right. So when you put it all out there and your fibers are like this, right, and you're starting to line them up,
yeah, keep going.
then the cleaving and they're putting the sleeves on and putting the cleaving. If they're all laid out like this and all you're doing is 40 seconds for each one, oh yeah, so much better.
Yeah, pretty quick.
Oh yeah, completely.
All right.
I mean, for me, by myself, it's when I was quick, probably a little under 2 minutes for each one. So if you're doing 40 seconds, I mean, that's half your time.
Yeah.
Cut it in half.
Yeah. Because I mean, most fiber jobs, they're not getting paid by the hour; they're getting paid by the splice, right?
Yeah.
So the more splices you get per hour is just that's money in your pocket.
Oh yeah. I mean, some people were, charge $50 a splice, $45 a splice, depending on what's going on. So some people do 25, they said, but 25 seems low. So anyway, let me prep this other side, and we'll do an arc test on it, and we'll see how good this thing is.
So how many splices would you say you've done in your years? You had to put a number on it.
Oh man, I had to put a number on it. I'd say anywhere between probably 7,000 to 10,000 splices, if not more. If not more.
All right, let me do something you're not supposed to do with this fiber. I'm gonna put a knot in it because that inner jacket's super loose, and when you try and strip it, it's just gonna slide on you. So obviously this is just for testing purposes. That way it doesn't run away on you. Because I was messing with it before, and we try and strip it, and then it would just go right through the tube.
It would.
Yeah. So, in the arc process, does it kind of arc before it lines them up?
No.
It only waits to, it only does that. I didn't know if it did something ahead of time to kind of clean up the ends or something like that. I guess it anticipates you doing a very clean cleave, and
It does, and it almost, when you watch it, it almost seems like, I mean, I don't know the process right before it arcs, but to me it looks like it almost like it does almost like a flash on it, like a photo. Like it looks at it and it says, oh, you know what, that cleave does not look right. Pull it back.
So that's what it's doing when it's doing that flash. It's looking at
the cleave. Yeah. And there's times, there's some machines that will take a cleave, and even if you think it's bad, it'll roll through it and it'll burn it, and it'll give it a good burn. As the more the sophisticated they've gotten, the more that they definitely don't do that. If it's a bad cleave, it won't handle it. But it also depends on the camera too. So there's a camera in here, and the angle of the cleave, sometimes how do I say that? The angle of the fiber, when it's looking at it, it may not show a bad cleave on this side, right? But on the other side, there's a bad cleave. Does that make sense?
Yeah. I noticed on the screen here it shows X and Y coordinates.
Yeah.
So I guess it has maybe even. Golly, Amber Alert. Let me ignore that. So I guess what are we talking about? Oh, yeah, the X and Y. So maybe it actually has two cameras inside looking at both axes.
And it does, and sometimes it won't even catch it. I've had one before. It looks like a perfect cleave on both sides, X and Y axis. It'll go through, and it'll pull together, and it'll arc, and all of a sudden it'll pull apart, and you'll see a bubble right in the middle of it.
So I did that guy's machine, like his fusion splicer, the one that was all in one.
Yeah.
I did see it actually do like a tensile test on the fiber after it fused. It kind of like pulled apart a little bit, I guess, just to make. I'm fairly certain this one doesn't do that.
I don't know. It looks like it's one of the newer generations, and most of them do that. It'll pull it apart right before you open it up. So these things right here, these arms basically will pull apart. It'll test its strength, and then it'll be okay. Now you can open It'll be like this. It'll pull it apart, and it says, "Oh, okay, everything tested. Okay, open it. Good to go." So let's do this. Make sure this one cuts well. Sounded like it did. Sure enough, it did.
Sure enough.
Okay, let's set it up. This cleave on the left side might be bad. We're gonna find out real soon. So for me, whenever I put these in, I like to put these as close as I can to the electrodes. Those arms don't move very far.
Oh.
I found out for me that it works out better that way because there's less chance of an error if these arms have to move too far. So I'll be like that. It's almost basically like millimeter across.
Yeah. I was gonna say, hang on a second. You get my calipers in there.
Oh, nice.
So if I had to guesstimate, it's going to be right about there. Yeah, it's about a 2 millimeter gap.
Yeah. Nice.
2 millimeter gap.
I haven't seen an electronic one before.
I'm lazy.
That's
I got it when I got the 3D printer, so I wouldn't have to work for it. But yeah, it's about a 2 millimeter gap.
Okay. Okay, so this arc test that we're going to do, and basically it's going to take these two fibers, it's going to arc and arc and arc over and over and over.
Really?
And basically it's going to test the arcs in here, right? It's going to test how well the electrodes are actually burning the fiber. So we're going to try it right now. It's been a while since I've done one of these.
Hit the menu button on it. It's weird. Like, the middle button is enter,
oh, okay.
One's exit.
Okay, let's try it. Arc test.
I keep wanting to touch the screen. It looks like a touch screen, but it's not.
Place fiber. All right, place the fiber. Okay, so you see how it is right now?
Mm-hmm. Yeah. So it's got the two fibers.
Yeah. It's aligning the X right now. You can see it move just ever so slightly.
Yeah.
See, on this side it looks good, right? But the X, the Y that it just did not look very good.
Oh, that just rounded it.
Mm-hmm. Arc power too weak. Okay.
Place fiber, prisoner. So this basically, how often do you actually have to do an arc test? Is it every time you get a new cable type?
You can do it for every new cable type. It's actually best practice just so you know what it is. For the most part, some of these are smart enough now that they recognize that it's multi-mode or single mode fiber. And that's unrecognized. I shouldn't say that. You can just set it to multi-mode or single mode fiber, and then you just put it in there. I shouldn't say recognized. It doesn't do that. It's always good to do it with new electrodes. You get new electrodes in there. Best way to test them out is put those in there, put a new fiber in there, and let that thing run over and over and over again. Kind of.
Well, I guess it might have like impurities and stuff too on electrodes, right? It'll burn that off.
Yeah, I mean, and it kind of tells you like, kind of like this. It says it's too weak, right? Arc power is too weak. It's good to know, especially with a new device. Another thing, those are the new devices as well. You get a new device, definitely do the arc test because you don't know what the strength is on it, how much it is. It's been a while since I've actually done this here. See if I do it again. I don't know if it's gonna like those cleats or not. I'm just gonna see
looks
what it
like
does.
a pair of Q-tips.
Yeah, didn't let me do it. Okay. Set too weak, man. I forgot how to set the power on these things. Okay.
It seems like an automotive would.
It should.
If it was too weak and give you a recommendation or something like that.
Most of the time, I would manually calibrate these things. It's been a while since I've done that. Just because that way I would know exactly what it's set to. Oh, good. Okay, see, the reason... Let's look at the pause. So the pause here basically lets you set the cleave, I guess you could say, beforehand, before it starts splicing itself. So the pause is always good. I like it because if it's bad, you can automatically pull it before it tells you. Does that make sense?
I'm not going to know what's bad. I mean, it makes logical sense, but I have no... I guess that's something you kind of get a feel for over time, right?
You do. What does it tell me? There we go. Someone set that to something. What is that?
The lightning bolt is modified? I
Yeah,
don't see a lightning bolt anywhere on this thing.
That's what I'm wondering.
That's all the buttons you got. Or
Nothing? Nothing on the back? Some kind of surprise? No? I don't know. Okay. I don't know what the lightning bolt is. Okay. Well, then we'll just leave that alone. We will... Okay, let's go back here. Multi-mode. I'm assuming he doesn't have nothing else in this thing. Nope. Okay. No,
So what is erbium doped?
I don't know, actually.
I've heard of that before, but I have no idea what it means.
Oh, okay. I used to know what that means. Non-zero is... what is non-zero dispersion? It's a type of glass that basically... There's less loss, basically. So, you know, when you have loss, everything, all the light gets spread out everywhere, I guess you could say. You know, on any bend you get, it's gonna, you know. So there's a glass that basically there's less loss. It's called Gorilla Glass. I don't think it's the same thing. Anyway, it's got a different heating point. That's basically all it is.
Oh, that's much coding.
Yeah. So, all right, get me out of here. Okay.
So the newer glasses, like the Corning bend insensitive stuff,
Mm-hmm.
do you have to, I mean, is that gonna fuse like any regular glass, or is it a little bit different?
Nowadays, it's not any different. I mean, for the most part, you can set it up and it'll burn just the way like anything else does. The glass has gotten so much better in so many different ways that, yeah, I mean, you can just basically set that bad boy up and it'll burn. Before, it used to matter, but the way the machines have gotten, the way the glass is, I mean, there's so much less work that you have to do now. There's not anything that you have to really do. So let me get this thing prepped again.
So, I mean, the fusion splicers you used to use were, what, like Fujitsu or something? Were they like really nice units?
Oh, yeah.
Oh yeah, they weren't. Well, I mean, like these units nowadays, I think you can get these for like $1,200
Yeah.
straight from China.
Yeah.
And you can probably get I don't know, 5,000 fusions or maybe 10,000. I don't know what the runtime on these things really is like. But what would you say? I mean, would you, if you were gonna start from scratch doing this, would you go and get yourself one of these cheap Chinese ones, or would you try and save up and get the kind of unit that you used to use?
I think it would definitely depend on the job. If you were doing something where you know you could take more loss, like for example, Fujitsu is definitely top of the line. That's where I would start if I was starting something right. But if you know you have a job where you're not doing anything crazy, but you're maybe connecting a few facilities together on a campus where it's not a great deal of loss, then completely go for it, because you can handle that loss on that distance. Right? You're gonna have loss, probably inside the enclosure as well. Just because of the cable and everything, you're gonna have a little bit of loss at all those points, right? Something like this, you can do that. Like I said, industry standard is 0.3. Most of these will give you at least a 0.1, if not below. Even this right here should. But if you're doing something long,
so you're saying like long haul fiber, you're probably going to need something that's more accurate.
Oh yeah, definitely, because at those points you need less loss at every one, right?
Right. Every little splice really makes a big difference.
It does.
Well, I mean, I know we were looking at doing some long haul stuff, and through optics and amplifiers, it looks like you can go like 200 kilometers without having to have repeaters or amplifiers or anything in the middle. Not having to do any regen. So it seems like if you're trying to go 200 kilometers, every little bit of loss could be, make or break for whatever circuit you're trying to do. So I guess that makes sense.
Definitely. If you're doing long haul, you're definitely providing some sort of service too. So you definitely don't want any kind of interruption at any point. I don't know if I like that cleave or not. But yeah, I mean, if you're doing something like that, I mean, you're providing more than just, internet connection. You're providing, a service, long distance.
Gotcha. But you're saying on a campus, or say it's, I don't know, say you're doing glass, it's less than 10 miles. You think this kind of thing would be fine for that?
Yeah, I think it would. I mean, because 10 miles, you're going to have a pull box every 600 feet. Or if you're doing on pole, let's say, I mean, you're definitely going to have one every probably, I don't know, let's say 10 poles, maybe longer. So you're going to have a chance to, I mean, you're going to have an enclosure along the way. So you're looking at maybe 1, 2, 3 enclosures at tops along the way. So if each one is at 0.1 loss, I mean, you can handle 10 miles.
Well, I mean, most like, I can get a single mode SFP optic that does 20 kilometers for about $7, brand new. So, being able to get good distance optics is really affordable. So, I mean, a unit like this is, I mean, it's almost, you got a trash can right down there. It's almost disposable these days. That's what I've heard from people. They say, we'll get these cheap units and we'll just have a spare on the shelf, or they'll always have two, right? Because they have a couple out in the field going, and if one breaks, they just throw it in the trash and get another one. They don't bother trying to fix them or anything.
True.
And I mean, say you're doing campus work and you're doing less than 500 splices a year or something like that. I mean, I guess it makes a lot of sense, right?
Oh yeah, it does. I mean, if you're not doing anything crazy, yeah. I mean, and especially if you can buy one like this and you can, quote unquote, teach yourself. I mean, you're saving yourself, plenty of man hours and plenty of dollars being able to put this together yourself.
Yeah.
I mean, it takes time, but I mean, to put a fusion splice together is not what it used to be. It's not like. I mean, I've seen an old splicer where you have to dial it in. I mean, you literally had. It was basically a box like this, and you're basically lining up each one every single time, and you don't have to do that anymore. Just like with the Cleaver,
like the alignment arms were automatic.
Yeah,
that's crazy.
Yeah, I've seen one, just a big old box, old school that people in College Station when they first were getting into it, is a big old box. I think it was Bayer. No. Oh, who's that one in Longmire? It's not Bayer. Who is that?
Oh, Britt Rice.
Yes, they had a splicer, right? The very first time they were getting into the splicing business, they had a manual splicer, about this big, like this, and they had to manually line up the fiber.
Poor bastard.
Oh, and it was a terrible job. I mean, terrible.
I guess it would never tell you had a bad clean.
No.
You'd burn every single one of those things.
Oh, yeah. So, I mean, okay. So, let's get this bad boy going.
So, I think all you have to do is hit the set button, and it will... So, it did the little flash, which I guess is it, sort of checking things. Now it's
There we go.
doing the X.
See how I did the alignment there?
Yeah.
Like, yeah, meant to do that manually.
Oh, dude, what a nightmare. So, why do you... Looking at the screen, it's saying right cleave bad. What looks bad about that cleave? Because it looks pretty darn straight to me.
If you... Okay, so the X doesn't look too terrible, right? But this, you can see how that cleave kind of rounds out. I mean, it's not much.
Oh, yeah.
But you can see how it...
Slightly curved.
It kind of curved this way a little bit. So that's what I'm saying. Sometimes the camera angles will fool itself. So like this one looks okay, and this one might look okay, but maybe there's a Z-axis where there's a different one that looks a little bit different.
So do you think if you twisted the fiber a little bit, it might change its mind?
It might.
And then go ahead and try.
I mean, it might. I've done it before where you take it out and you put it right back in, and it says, "Oh, it's okay now." But to do it right, you know, especially if you're doing it, if you're getting paid for this job, yeah, you better take that thing out and get that thing right. But yeah, so like I said, it's not much, but you can tell. No, just because I'm used to seeing it, you can tell it just bows out just enough.
Well, if you hadn't said it, I wouldn't have known what to look for. But yeah, you can definitely see the shape of the cleave is different between the two. That one does look, what is that, convex? Now it looks a little concave.
Yeah,
I guess. So how important is a good cleaver?
Oh, extremely important. I mean, that's basically the foundation of the whole fusion splice, right? If you don't get a good cleave, if you don't have a good cut, then you're constantly, as I told you before, like you're constantly sitting here and you're cutting it all over again. Same thing with a good splicer. If you don't get a good arc, it's the exact same thing. If you don't get a good cleave, you're just wasting your time. Because then you're going to do is kick this out. You're going to strip the cable back again. You're going to take some more of the cladding off. You're going to set it back in there. You're going to cut it. And if you're not getting a good cut, then yeah. And most of these things are diamond tipped. They'll tell you that. Most of those cleavers are diamond tipped. This one right here. So it's supposed to be perfectly good cut. So.
Yeah, I was reading about how you can adjust these things. Supposedly there's these two screws, you loosen those, and then this screw right here, you loosen that, and then you go down in that hole, and there's like, down inside the hole is like some adjustment knob that will raise and lower this thing. I have no idea if it's
and it's minuscule.
Not.
I mean it is, and you can make this thing crooked too. I mean that's what the tough part is about this. I mean you can get this thing back in there and it'll look just off just enough, and it makes a difference. And you'll notice it when you start cleaving. All of a sudden you're just like, what the heck, you know? That's why it's always good in my head as a professional that you have 2 or 3 of these bad boys. You have one that you always rely on. You have a backup, and there's the mechanical ones that are always good to go, where you basically cleave it manually and then break it. Sometimes those things are even more money than these are.
Oh, they look like little flexible pieces of plastic or something. I've seen those before.
And you tap it and it breaks.
Huh.
And sometimes you get better cleaves than these fancy bad boys because these are expensive too. I've seen a guy that he did the same. I mean, he was old school Verizon guy that I used to get tips from, and he would use that every once in a while. He said every once in a while this thing would just be money for a day, and I'd get something better than I get off of this.
That's crazy.
And this.
It sounds like a little bit.
Oh, it probably was, but he
swore by it.
He swore by it.
All right, man.
So, all right, let me try this again. Let's see if this cleave looks better this time.
So yeah, just from the amount of work. Well, I mean, because like a pigtail, you've only got so much fiber there to work with.
You do.
You know, so if you have to keep stripping and cleaving. I mean, you lose.
Oh yeah.
You lose what, like a ½ inch every time you have to redo this?
Basically.
Yeah.
And if you don't set it out the first time right, then yeah, I mean. So another thing too that's good or good to know about is the wipes, right? So basically, I always use one of these things for 10 wipes.
10 wipes.
10 wipes. That's just me. Some people do it where they take one and they throw it away. I'm like, for me, that's just too much. The frugal part of me is like, okay, I'm not gonna do that. I might fold it a different way like this, and I might fold it a different way here every time I use it. But I'm not gonna throw one away after one wipe. Some people do that. That's just not me. I couldn't do that. It's a waste of money in my head.
Gotcha. If you're the one buying the wipes, it's hard to convince yourself.
Oh, yeah. So, yeah. But, yeah.
Alright, it looks like it's cleaving every time.
It does, though. It seems to be a pretty good device, actually. It seems like it's doing well. I've never actually used that brand before.
It's straight out of China.
It's okay.
Because I looked up the model number and I can only find it like on AliExpress.
Dude, did you read this interesting stat I read today?
Probably not.
Okay.
I don't read much news these days.
Oh, it's not news. This is an interesting stat.
Oh, okay.
Okay, so you ready?
Yeah.
Okay, so basically for the 20th century, the United States has used 4.3 gigatons of concrete in all of its, whatever it is, roads, buildings, whatever it is. Whoever came up with that number, I want to know, because I want to know who you talked to about how much you used. Sorry, I'm not staying focused here. Anyway, in the past, I think it was 3 years, China has used 6 gigatons of concrete in just the past 6 years.
So what was the original stat?
The United States uses 4.1 gigatons in basically the whole 20th century of concrete. And in the past 3 years, China alone has used 6 gigatons.
God, nearly the same amount. That's insane.
It is, though. Why is it not lining up?
You know, a stat I heard the other day that was pretty interesting is Dubai imports more sand from, I think it's Dubai, imports more sand than anything else, and they get it all from Australia.
No way.
Yeah, dude, because supposedly it's a land poor environment, so they basically have to bring in sand, make concrete to dump out in the ocean to make the country bigger. And so their sand is too fine, but Australia and Outback has a lot of really good coarse sand. All right, so it's lining everything up.
I don't like that right there. I don't know if I would go through with it or not.
It's thinking about it.
I did it.
Yeah.
And I don't let that burn. Okay, so it says 0.01 loss, right?
All right.
That's the loss on it.
And I'm looking at the Y here. It looks like a continuous straight reflection. It was this one. You see a little divot right there where it did the fuse.
And you're gonna so a good splice for the most part you're gonna if you had an OTDR, right, which is basically the fiber testing kit.
Which I think I'd actually have something.
If
You might look at that.
on an OTDR, especially off an Expo is top of the line stuff, right? It's gonna notice that, right? It may say 0.01 here, but when you do the reflection, when you do the testing and the reflection comes back, it might say that it's 0.34, which is still within plenty of standards, right? It's not a problem, right? For me, I would cut that and do it all over again because I know it's going to show up on the OTDR, right?
Right.
And I want little reflection as humanly possible. And if you did 1550, which is basically your testing, your testing light that you put down the fiber. 1550, it'll definitely show up for sure.
Really?
Yeah.
I think most of the single mode stuff we do is 1310.
Yeah.
Which is going to be, I guess, more your short haul stuff.
1310 for the most part is most common to use. And it's not short haul. I'd say you could go probably 10 miles with that 1310. But 1550 is definitely something that you use more long haul, and that definitely shows up a lot more. And it's also for your testing as well.
So higher frequencies are more susceptible to reflection.
Oh, yeah.
And things like that. All right.
So knowing what you're doing, depending on what it is, if you have a long haul, then yeah, I would say that's no good. I'm not going to do that. I'm going to cut that. I'm going to do that all over again.
Gotcha. But if you're on a campus, you're within 5 miles, 10 miles.
You could keep that.
No worries.
Oh yeah. I mean, you're going to see it when you OTDR it, and especially and if you remember what you did, you're going to remember like, oh, that's exactly where it is. But for me, yeah, I would cut that and do that all over again.
So other than you're going to get some reflection, you're going to get some loss there. Is there any danger of strength? Like, I mean, do you think it's any weaker? There's no
danger of strength. People, I think, sometimes underestimate the tensile strength, especially of fiber. Excuse me. The only time I ever worry about fiber is 2 times. When I'm pulling it, under what, because I don't want too much pressure on that cable when I'm pulling it, right? And the other time is the bend radius. Another time, other than that, no, I don't really worry about fiber. People are really gentle with it, and I've learned over the time that it's actually a lot stronger than you give it credit for. You don't have to baby it, I guess you could say.
Yeah. Well, I mean, I had that bare piece of glass out before when it was stripped, and I was just seeing how far it would go.
Yeah.
I mean, it'll curlicue.
Yeah.
It'll go all the way around. So
some of the stuff now, some of this Gorilla Glass, you can tie it like this, and supposedly there's no loss. You can, and you can clamp it down tight, and there's no loss.
that's crazy. I saw whenever the Corning bend insensitive stuff first started coming on the market, we had, I think maybe it was Corning. I don't remember what vendor came out, but they plugged it in. They had their light generator and their signal meter, and he took a pencil and he wrapped it.
Yeah.
And it's like it didn't exist.
Yeah.
And then he just we got one of our jumpers out of the bin and plugged in, and one twist, and you could immediately, it just immediately, it was pretty crazy stuff.
I like it. I like it for outside plant stuff. Inside stuff, I don't like it because you can get an SFP that's just blazing hot, and when it comes into the other side of the switch, it's just too hot. And if you don't have anything to temper that, to even a couple of loops that help on a patch cable, it burns that thing up. Because it'll burn it out. So I like it in my outside plant. I don't like it in my inside plant because sometimes you want to be able to, especially if something's coming in too hot, and you can tell that on your light meters. I don't want to burn my SFP up, right? So tamper it down by one coil maybe, and it could be the right dB coming in. So
all right. So now that the burn is done, is there something special you do to pull it out? You just open the top and
open the top, and it should do a strength test while it's doing it.
Yeah, stretching test. There it goes.
It's gonna do it. It's ready to go.
Ready to go.
So if I had my jacket on, I'd pop that bad boy in there, and we'd be done. So, and sometimes, just because I've done it a lot of years, sometimes I can look at it and I can see the actual splice. I'm like, I can see that thing. This one I can't, which that's good, because I thought I would be able to after that little burn. Oh, maybe I can. Looks like it's right there. You probably won't be able to see it, but there's a little bit of a mark where you can see it.
But you're working hard to see it.
Oh yeah. Yep, I can see it right there. It is definitely, and that might be the side that we saw, because this side, I can't see it as well. And that might be the side that we saw. But yeah, you can see it right there. Yeah, plain as day. That would bother me.
It's not plain as day to me.
That would bother me, because I would definitely take that thing out. So, because you can, there's sometimes you can, it'll burn so bright in there. Yeah, I can still see it now. I gotta put it against that contrast right there, something darker. But yeah, just see it.
But you can see it.
Yeah, but and then another way too. Cleaves too, the same way. If you hold a cleave up and you look at it, if it's bright at the end, it's not good.
Really?
Yeah.
That means there's some kind of angle that. Oh.
Yeah. It's weird because even when you put it down here, if it's a little shiny, you're like, that's a bad cleave. Even before you close it, it's like, that's a bad cleave.
So how often do you have to re-cleave on average? Would you say out of like 10?
Out of it, let's say a 48 count outside plant cable that I'm putting in, that I'm pulling inside. On re-cleaving, I might have to re-cleave. If it's a good cleaver, maybe 4, 5, 6 times tops.
Oh, that's not bad.
That's not bad.
That's not terrible.
No, and you didn't, and that's just because maybe you're in a hurry. Maybe you didn't place it in here right. Maybe it sits at an angle when you first put it in. There could be a lot of things.
A whole lot of different.
Yeah. So, yeah, 4, 5, 6 times. You're not talking a lot. You having a bad cleaver day is when you're getting like 10 times or multiple times on the same fiber strand. You're like, oh my goodness, like this. Like, throw this one away and let's get the other one out. So yeah, it's not like you said. Sometimes it's voodoo. Sometimes because this one may go for a long time and it may not let you down. Then all of a sudden one day you hadn't touched it, everything is the same, and it just won't cleave. And you're just like, I want to throw this thing out the window.
I got stuff to do. I don't have time to mess with this.
Exactly. I got to get home. So, how
about maintenance on these things? Is it usually just change the electrodes and that's it? Do you ever have to clean this thing?
Yeah, you do. You definitely.
Or do you use like compressed air or something? Or?
No, don't use compressed air.
Never use.
Don't use compressed air. No, definitely compressed air is bad for the electrodes.
You use like
I've done that once, and the veteran guy that I would always go to, he's like, "Don't do that." He said, "I've had bad results with that. So I'm not telling you it's bad. I'm just telling you that from my personal experience, it's never been good." I was like, "Okay, perfect."
Interesting.
Yeah, he said it's messed up stuff the next time he went out with it, it just wouldn't burn right. And I don't know if it was burning excess stuff that was caught in there or what. It just wouldn't burn right. So he said, don't do that. You can use a Q-tip. You can use like a fine hair like a paintbrush. And basically what you would do with that is basically you're just taking all the strips that are in here and basically just wiping them out. Right? You're going to take this, you're going to wipe out anything in here, wipe out anything here. Because, sometimes you're in different environments. You might be outside all day. You might be inside. Sometimes you're in a place where the wind is kicking up and there might be dust on the ground and you can tell that it's kicking up all over here.
Right.
So yeah, just take a little fine hair brush, wipe it, especially before you splice and definitely after you splice. Not each and every time. I know before you start your job and after you finish your job. And then for the most part after that, no. Make sure your electrodes are clean. And like I said, this one right here, you can tell. You can just tell really bad that it's been burned quite a bit.
I wonder if that, because I don't think there's that many actuations on this thing. It makes me wonder, is that actually the probes are worn out, or is that just an artifact of using a cheaper fusion splicer? Maybe
I don't know, and it could be cheaper electrodes too.
Yeah.
There's always that. Now, for me, I would want to replace those electrodes, and that's just me. But again, if they're giving you good burns, you go as long as you can because replacing electrodes. It's like the wipes. You don't want to waste your electrodes. You burn it till it won't burn anymore, basically. As far as other maintenance is concerned, like we did before, did the arc test. You can actually calibrate this thing too, and it's always good to do. After, I think the standard recommendation is after like 500 splices, it's always good to do a full calibration on it. And then again, when you get new electrodes, always do a full calibration on this thing. Let it go through, because it'll go through to do the X, Y, move it left, right, make sure it lines up correctly, burns it, all this other stuff. So definitely calibrate. It's definitely good. And then I don't think it's every year, I think it's every 2 years. Standard recommendation is to send this thing into the manufacturer, and they'll go through and basically do a whole clean, updating the software on here, and send it back to you completely revamped.
Gotcha. With these cheap machines, I think after 2 years you throw them. I really do. I think you just use these things till the wheels fall off, and then you just pick up another one.
I mean, like I said, this one looks pretty good. I'm surprised. Thought it was going to be a whole lot less whenever you showed me, but it's not bad. I mean, yeah, a couple of years and resell this bad boy, clean it up and resell it. I mean, I don't see why not. Give it to somebody that's trying to get started.
So, pass it off to some other sucker.
Yeah, pass it off to somebody else who's trying to get started in this crazy world.
All right. So I am not sure what this thing is, but I've got this big monster thing. Hang on just a second. Let me.
Does it need a battery?
I don't know. I think it's trying to tell you that it's got OTDR capabilities. I'm not sure if that's 100% the truth, or it says Komshine on it, right? So it's the same manufacturer as the Splice. Well, you know what? I say it's the same manufacturer. That doesn't mean that they actually made it and didn't just stick their own label on it or whatever.
That's true.
But supposedly no TDR.
Oh, here we go.
Is it coming alive? I don't actually have any working cables to test it with.
It's okay. We can do that. Nope. I'm not power enough. Is there a different battery in here? Or a plug? Is there a power cord?
Yeah, I got something in here. Is there a port on the back of it?
Yeah, there's a port right here. Right there, it says we can plug something into it.
Does it say 15 volt?
Is that what it is?
15 volt? There it is.
Hook it
This
up.
is it.
Oh, yeah, power. Or not. Give it a second. Maybe it takes longer in Chinese to boot up.
Oh, maybe you gotta hold it down.
Yeah, maybe so.
Yeah, there it is.
Oh, snap.
Oh, Komshine.
Look at that.
It's got their logo on there and everything. So it says it's got a VFL, was it a visual fault locator?
Mm-hmm.
So basically it just shoots a laser down so you can look at the end of the fiber and see if something's there.
Mm-hmm.
Alright, so this thing looks like it's got a USB port and even an SD card slot, so I'm assuming that means you can store results on there.
Yeah, you can. And good practice is always to store your results. Because you want to do that, because if for some reason they come back to you later, whoever you did the job for says, hey, my fiber's not working, or hey, you did this wrong, or hey, what were the results? You pull this bad boy out. Maybe you have it on your Windows desktop. Sometimes this comes with software too that you can put on your desktop, and you can just pull the files and put them on there. And anyway, yeah, pull them out and say, hey, this is what it was. Whenever I finished the job, this is exactly what it was. This is where the faults were. This is where the losses are. Blah blah blah.
Basically, this is it showing that I did everything right.
Yeah.
Yeah.
So, let's see here. The VFL didn't come up. Sure as hoping that it would.
I think I've also got some other random stuff in here.
Boom! There we go.
Whoa!
I need some red light.
Yeah, there it is. Tells you about it.
Yeah. Look at that. I like that. Okay, this is always good to have too.
So it's definitely a laser, right?
Oh yeah, you never,
That's
never,
not a diode.
never stare into that bad boy. That's why I put my hand there. So if I was coming out, don't stare into that thing. Oh yeah, this is good to always have. This basically helps you, especially if you're doing short distances. This is very helpful right here. So, because if you can't, because what you can do on this thing, so, let's say you have a bad splice, right? All right, so you put this. I don't know what you want me to show you about this stuff, but for the red light, this I always thought it was very helpful in this aspect. So basically, you put a connector, you put on this side right here, and let's say this part is your enclosure, and you're trying to figure out, well, where the hell is the bad fiber? You know? Ooh, see, look at that, broke. So what ends up happening is that the red light will just kind of like I told you earlier. If there's a bad cleave, it's going to shine bright. That red light is going to shine bright.
Oh,
so if there's a bad splice, like right here, there'll be a red light, and you'll see it plain as day.
Gotcha.
And same thing. If let's say you say your splice is good, right? But you're still like, I can't figure out what's going on. If you bend the fiber, it'll show you the red light. So if you have a bad fiber along the way, let's say it's in your enclosure, it'll light up like crazy here too.
Oh, right.
So if you have a broken fiber, you're like, oh, that's what it was. It was not my splice. It was the fact that this fiber was broken right here already.
Yeah.
So, like anything else, you know, when
right
it
by
breaks,
the enclosure door.
exactly.
Yeah.
Oh, hey, I've had it happen, man. I've had it happen, and you're just like, that doesn't make any sense. Why are all of them good, but except for number, I don't know, 39? And yeah, you'll have this one right here, and you'll see it just like, oh, dang. There's nothing you can do about it. So, yeah, marks not good. Okay, so let's look at the OTDR mode. Let's see what it does.
So OTDRs, I was at Wispapalooza. They had these guys, Millennium. They're like I guess a distributor or reseller of fiber and fiber equipment, and they had this sweet little OTDR that gave you this block diagram, and each different colored block was like a different thing. So if it was a blue block, that was a connector. If it was red, there was like a cut or a break.
Okay.
If it was like yellow, there was a bend. And so it was like you didn't have to try and interpret this interesting curve graph thing anymore.
That takes the fun out of it. There's no fun in it anymore.
It's great for idiots like me that don't know anything about it.
Okay, so I don't have a cable on here, right? But if I did, so what this thing would show you right here is that this is the launch point on the left side right here. Okay, so this is your launch point. So it's always going to be high, right? So just like anything else, you're gonna have loss along the distance, just like anything else, right? You're gonna have attenuation, you know. So let's say at this point right here, I have a blip, and let's say that's that splice that I just did. Then I would know at what distance it was at. So if I'm trying to troubleshoot something, or I'm like saying like, oh, you know what, I know where this is, and let's say the next splice point is at this point right here. Let's say it's another 1,000 meters away, and I have a big spike and a big drop, then that's a totally bad splice. Maybe it's a bad patch panel, bad connector there. Maybe you have to wipe the connector off put it back in there. So this basically shows you every point of reflection, right? So basically, it's going to
How do I know distance though? Like on this thing, like how do you tell how far? Are they all just a little bit different? I guess.
You can most of the time you can set it a certain way because there's different distances, right? So you can have a distance of, let's say it's a mile. You can have a mile on here and it'll show just that mile. Or you can have the whole run, maybe it's 20 kilometers, and you can have the whole 20 kilometers on here.
Oh, so if it's like, if you know the run is 20 kilometers and it's 50% of the way, it's about 10 kilometers in.
Yeah.
All right.
Yeah.
Well, I mean, can an Otdr also tell you how long it thinks the cable is?
Yes.
Like in total?
It can. It can tell you that. And the bad thing is it's not always, these are more accurate as far as the distance is concerned. Does that make sense as far as the actual length of the cable, right? Because on the outside markings of an outside plant cable, you're going to get that it's, I don't know, maybe it's 5 kilometers, right, on the outside part of the cable, right? And you're going to get markings on there. But the actual length of the cable is actually longer than that because of all the twists, right? Because it's going to twist like this, it's going to straighten back up, and it's going to twist back the other direction, it's going to straighten back up, it's going to look the other way. So it gives you the actual physical distance of what your actual cable is, not the metering on the outside of the plant.
Right. And it does that by getting to the very end, and then the light will reflect all the way back. So it's not going to get like false positives from like bends and connectors and stuff like that.
It can, depending on how bad it is. If you have a bad connector or you have a bad bend, yeah, it'll think that it ended right here, when in actuality it ended way over here.
Okay.
So yeah, if you have a bad connector or you have a bad splice or something or a bad bend, it might drop off completely right here and say that the cable is only 3,000 meters long, when in actuality it's 6.5 kilometers long.
But I guess, I mean, if you're running cable, you're not running just one cable. So if you put an Otdr on 6 different cables and they all tell you the same thing, you know pretty well that that is the actual distance.
Yeah.
If you have one cable and all of a sudden is, 20 or, I don't know, 15 or 50 meters shorter, then maybe there's something a little fishy with that one.
Oh, definitely. Maybe, and sometimes that going into it, because sometimes maybe it's the box that you're going into, maybe it's the bend on the actual conduit, so you'll know like, oh, okay, maybe the cable that we pulled in, maybe we pulled it too tight and it's bending too hard against that conduit, stuff like that. There's physical things that that you know about, I guess you could say, where you can kind of point to like, oh, okay, maybe that's what that is. Because sometimes it's not always the cable. Does that make sense? Sometimes it's the physical conditions that it's actually under. I keep hitting that.
Something. Yeah, no worries. Something that I heard some fiber guys talk about is they said every connector is dirty. So when it comes from the factory, it's dirty. When you pull it out of a plastic package, it's dirty. So you should clean every connector. Is that?
You should clean every connector out of best practice. I wouldn't say that every connector is dirty, but I would clean every connector out of best practice.
Okay.
Because there's a scope. There's actually a connector scope that you can actually take it on there, and you can actually, on some of the devices, the Otdr, you can actually hook it up and you can actually look directly onto it. You put it on there and you'll look on the screen right here and you look at it and it's like, yeah, you just put it out of the package and it's dirty. And you can wipe it 1,000 different ways, and every practice that everybody knows, and it's still probably going to show up a little bit dirty. So what they're saying, yes, is probably true. In my head, I don't think of it that way, but probably every connector is probably dirty.
So whenever you plug in a fiber optic cable into an optic, does it actually make physical contact with the other end of that optic? Is it literally touching the laser on the other end?
Yes.
All right. So if there are impurities, if it is dirty, that's going to get on your optic.
Yeah.
All right.
Yeah. So, and the physical gap too. I mean, as much as you want to say it's touching together, right? There is still a physical gap in between. It's not going to be completely flush every single time.
Not every bit of it.
The only thing that's really good, and a lot of people are using these a lot more, are APCs, which are these angled.
The angled fiber, right?
The angled fiber is actually so much better now.
That's interesting.
Than the UPCs and everything else.
So if this was the end of the fiber, it's actually going to be at like an angle.
Yeah.
Right? So that the other side of the fiber will actually meet up with them.
And you have so much less reflection, so much less loss.
That's what I heard. So, and some guys I know that are doing, they're doing DWDM, like dense wave, coarse wave. They say that on all their installs, they have to do the APC connectors.
Yes.
Because if you have just... if you've got 10 channels and you're only using the first 4, those other 10, you're actually, if you don't have them APC, they're going to start losing light, get reflection, have issues.
Yeah.
And
more people are doing that.
I had never known that before.
Yeah. For the people that are doing that dense wave stuff and people that are, I mean, you have to have a clean, flush look. Otherwise, you don't get to use the full capacity of what you would like to, I guess you could say. Does that make sense? If you're not getting a good, clean, flush fix, you know, with the angles like this, the UPC is like this. It's all, which is ultra polished, you know, connector. It's be like this. The angles, it's just, I mean, I don't know what it is, but it's so much cleaner. So
that's interesting. So inside this OTDR, there's a laser that's going to fire out of there, and if you plug in a dirty optic, you're going to get this thing dirty.
Yes.
If you get an optic dirty, how do you actually clean an optic? Is there a way to do that? I know I've seen they have those little click cleaners, but I've always seen them use that on the end of a fiber. Do they make one that actually will go through a coupler and clean the other end?
There's so many different products now that you could use. I always like the clicker tape. So the clicker tape is basically what same thing probably talking about. It's a box, right?
Yeah.
And it's got you open it up and you wipe it, you twist it and you wipe it down at the same time. And that was my preference. People like to use different things. People like to use a Kim wipe the exact same way. And some people, that whatever you're in the habit of doing is what they stick to.
Gotcha.
So it's what everybody's preference.
But you'd say don't use your t-shirt?
Definitely don't use a t-shirt.
I've used my t-shirt. I've done that.
Hey, to each his own, you know?
Yeah.
And if it gets the job done, I mean, if somebody's back up and working, who's to complain, you know?
Yeah.
But yeah, if you're doing it professionally, there are those ones at the end you can basically clean the tip of real fast. But I always use like the clicker tape. Clicker tape, you get a clean wipe with it. You click it again, that way next time you open it up, it's ready to go.
Just these things.
Yeah. Some people like to do the old school stuff too. Even like, you know how you polish one, a connector? And you basically put it down and you like kind of like figure eight it?
Yeah.
Some people like to do that still. So, and like I said, that's whatever they swear by.
Yeah, I think I remember seeing one of those clickers. Yeah, here's one. Like a little clicker where you pop it off.
Now this right here is mostly for your patch panels. These are very good for patch panels.
Yeah.
So you go in there, done, real fast.
So anything that's on the other side, it'll clean them out.
Yeah.
Blah, blah, blah.
Yeah.
Nice. That's basically like dental floss inside, right? That
Basically.
pulls through every time you click.
I'm assuming so. I've never actually opened one up. I've only used these things a couple of times. And mostly I use it for, I pull it out very rarely for certain losses at certain points. Yeah. Because most of the time what I enjoy doing, and I think it's a better practice too, is to already have a pre-terminated panel. So your panel comes from the manufacturer already done. All you do is have a cable outside and you're splicing that up, and that's so much easier.
Yeah, I know the NPO, NPT connectors are starting to get a lot more popular.
Yeah.
Like the cassettes, and then a lot of times fibers will be preterm on both sides. You can preterm NPO on one side, you know, and that way you just do your splicey stuff on the other side.
So at some point, I think that fiber splicing will probably not go away, but they've got so many ways to just automatically almost like plug and play, basically.
Yeah.
Put it together. There you go.
I'm looking for at some point where it's a machine where you just cut the end of the cable clean, you put it in there, it'll strip it, and then you move it, and it'll cleave it, and then you put it down, and then do the other side, and it'll fuse the crap together. You don't have to think about it.
Yeah. So
idiot proof.
The same thing is even better too with same things are true with what is it called? I can't think of the cable now. Basically, it's like 10 strands put together. I can't think of the name. So basically, you cleave 10 strands at the same time.
Oh, wow.
Yeah. You seen that
weird.
one?
Nuh-uh.
Okay, so they have splicers that will do that, right? So you can, in a cleaver that'll do the exact same thing. So instead of splicing one wall, so it's mostly the really dense cable that you can get, and you can do it however you want to. You can even order a 48 cable that comes in this way, but you can have it where basically you'll have, I don't know, let's say.
Is it like a little frame that they all fit in? And
yeah. So
they're just like locked in there, and you just kind of move these little things around.
And you'll have it like, I don't know, let's say I think it's 10 you can do. It's 10. It'll have a cleaver that will cleave all 10 of them, and you lay it in here. It'll line up all 10, and if you're good enough, it'll splice all 10 right away, and you'll have 10 splices just like that.
Boom.
So, but most of the time it's the heavy stuff like 288 count fiber you want to do that with.
That's gonna be a big machine too, right?
Yeah, it's a different machine. And sometimes it's not a different machine. Depending on the machine, you can actually take these arms out and you can put arms in specifically just for that.
Cool.
Yeah.